So when we are creating our recursive equation, a sub 1 refers to the first term in our sequence, in the sequence. What do you think a sub n is?
Any given term?
Any given term, you could call it that. I would say your current term. So the term that you're dealing with, the term you want to know. So a sub n is the current term. The term you are trying to solve for. What do you think a sub n minus 1 is?
The previous term?
Yes, it's the previous term. And a sub n plus 1. The next term. So, there are two types of recursive equations based on your set of data. So, if your terms increase by the same amount every time, what type of equation do you think this is? So it's between linear, quadratic, and exponential. If they increase by the same amount every time,
Linear.
it is linear. Yes, this is a linear equation. So here, what did we increase by to go from 5 to 13? 8. And what did we increase by to go from 13 to 21? And 21 to 29? Are we increasing by the same amount every time?
Yes.
Why, yes, we are. So we have proven that this is linear, and we use this equation, this recursive equation. You always put a sub n first. So a sub n is equal to the previous term, a sub n minus 1, and then you put the amount you increase by. And then you always have to state the first term in your sequence. So a sub 1 is equal to 5. This is the first term in the sequence. Now, as a side note, what is the difference between how this sequence looks versus how a quadratic sequence would look? Multiply means what, actually? Exponential. So if we're multiplying each time, that's actually getting exponentially larger, right? So the difference between linear and quadratic, and the difference between quadratic and exponential is, so say if we had, I know there's not much room to write on these notes, but say I had the sequence 1, 2, 7, 11. Okay, so what increase is happening here? What is our first increase? It's called going from 1 to 2. What do I go up by? 1. Going from 2 to 4. What do I go up by? Going from 4 to 7. What do I go up by? Going from 7 to 11.
4.
So are my increases the same?
No.
No, but what do you notice? Your increases go up by an increase of 1. So this is called your second increase, like your second level of increasing, right? The first level is the first time you figure out what you're increasing by. Then the second level is called your second increase. It's the second increase you're finding. So when second increase is the same, it is a quadratic. Because we're not in the quadratic unit, we won't really be touching this very much. Now, what is the difference between linear, quadratic, and now exponential? What does exponential do that the other two do not? It multiplies. So on this example here, what is happening from one term to the next? You're multiplying by 5 times 5 times 5. So that makes this what type of equation? Exponential. First one was linear. So we start off the same way. A sub n is equal to, but this time, because we're multiplying, you're going to multiply your previous term times the amount you multiplied by. So here we multiplied by 5 each time, so it's 5 times the previous term, a sub n minus 1. All that this means is, say we had 10. We were trying to figure out what this nth term is right here, the 50. And we knew the previous term was 10. What would our equation tell us to do? Multiply, what's our previous term? 10 times 5, and what do you get? 50. So that's how you get the current term. So recursive, is recursive equations as useful as regular equations?
No.
They're not quite as useful because you do need to know the previous term. Yes. All right. So now, and then also make sure you list your first term. A sub 1 is equal to 0.4. Do you want me to do one more example? Or do you think you can do it? Well, I'll do one. So, what is happening here? Are we multiplying or adding? Multiplying by what? So how am I going to start off my equation? A sub n is equal to am I adding or multiplying? So it's 2 times a sub n minus 1. And then what was my first term? 2. Done. I've created my recursive equation. I am done. All right, you guys try 2, 3, 4, and 5. And 6, sorry. 2, 3, 4, 5, 6. Go ahead. Yes, a sub n is equal to, yes, 0.5 or 1/2 times a sub n minus 1. And our first term is? Beautiful. You can also write it as a sub n minus 1 over 2. Number 4, Ella, what'd you get?
I got 3 times.
Yes, 3 times a sub n minus 1
And then a sub 1 is 2.
over. Good. And Allie, what about number 5?
I got 2 times a n minus 1, and then a1 was 0.01.
Good, 0.01. And Allison, what about number 6? All right. Cleo, 6. Number 6. Yes, a sub n minus 1 over 9. And our first term is 18. All right. So now we are going to, yes, write the recursive notation, but we are also being asked to write the exponential equation. Now, either you can remember the pattern for writing the exponential equation, or you can use exponential regression. Can someone let Austin in? Now, now if we wanted to use our calculator to find the equation in exponential form, what do? You press stat, then what? Edit, and then we're given this that has multiple lists. What am I inputting here?
Your X and Y value.
Your X and Y. Now what goes into L1?
X.
Your X values. So I'm going to put 0, 1, 2, 3, 4. And what goes into L2? 81, 27, whoops.
0, 9, 27, 81.
9, 3, 1. Then what do? Press stat again. Calc. Does anyone know where we go? Yeah, all the way down till it says expreg. Expreg. Exponential regression. That's 10 actually. I know it says 0. And you press enter. Enter, 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 enter. Enter.
You get an error.
You should not get an error. You should get a times b raised to x. Now, your a term is what? 81. Your b term is, what's another way we could write 0.333333?
1/3.
1/3 raised to x. So here, y equals 81 times 1/3 raised to the x power.
All of it or just the 1/3?
Just the 1/3. Now, does anyone see how I could have gotten these values without using my calculator?
Going from your lowest value up.
Where do you think this 81 came from?
The first number.
It is the y-intercept. It is called your zero term, right? Not your first term, but your zero term, we're going to call it. All right? And then what about that 1/3? Where could we have gotten that 1/3 from?
Divided by 3.
Yeah, what happened each time?
Divided by 3.
We divided by 3 or multiplied by 1/3. So all we have to do here is figure out, okay, what are we multiplying by? That's what's raised to x. And then what is our zero term? That's what's multiplied in front. And we're done. If you can't remember that, go ahead, use exponential regression. That's fine. Now recursive. What does the recursive look like on this problem? Yes. And then what's our first term? Yep. A sub 1 equals 81. Now let's try to do this. Well, do you want me to do one more or you got it? I think you have it, right? All right, you guys go ahead and for the next 10 minutes, do this problem and the problems on the back.